we have a quadratic equation, 4x squared plus bx minus 5 equals 0. So we know it's a quadratic because the highest power of x is x squared. We know it's a quadratic equation because we have that quadratic expression in an equation and it is equal to 0. So what is this b about? Well, that's actually what we're looking for. So b is just some number. It could be 1, it could be negative 25, it could be a billion. We don't know. But what we do know is that this quadratic equation has these two solutions. So we need to use the solutions and kind of reverse engineer what the quadratic equation is so that we can then work out what the value of b must be for this equation to have these two solutions. So maybe just before we tackle this problem, let's just remind ourselves of the steps of solving a simple quadratic equation. Something like this. Right, so quadratic equation, we find two numbers that multiply to 3 and add to positive 4. So that would be x plus 3 and x plus 1. Right, so we've factorized it, and now to get the solutions, we need to set either this bracket equal to 0 or this one equal to 0. Right, and we do that because two factors, right? So this is one factor, this is another. For it to equal 0, 1 must be 0, right? 0 times anything is 0, or anything times 0 is 0. And then in solving for x, we get x equals negative 3 and x equals negative 1. So we have our solutions, and in this problem, we're actually going to be going backwards this way, right? So start with our solutions to go to the quadratic, so we can then find out what b, the value of b. Alright, so if that was enough to get you started, maybe try it yourself, but let's go through it together now. Alright, so we know it has solutions of negative a half and 5 over 2. So if we put it in its factorized form, instead of negative a half, we'd add a half, and instead of plus 5 over 2, we'd minus 5 over 2. Like so, and that must equal 0. Now, just looking back at this quadratic, the coefficient of x squared is 4. So if we were to expand this out, we would get x squared. So to get it, to adjust it to have a coefficient of 4, we can multiply it by a 4 out the front, so that when we expand it, we do get that 4x squared. Right, so now we've put it in factorized form from the solution, so now let's expand it into the standard quadratic. So we get x times x is x squared, x times negative 5 over 2, negative 5 over 2x, half times x plus half x, half times negative 5 over 2, negative 5 over 4. That equals 0. Now we can distribute the 4, which gives us 4x squared, which is what we expected. Then what do we have here? Minus 5 over 2x plus 1 over 2x. That's minus 4 over 2x. 4 over 2x, which is minus 2x, right? Just grouping those terms. But we need to now multiply it by 4. So that will be minus 8x. That was quite a few steps in one, so actually let me just put in a middle step here. So grouping like terms, that becomes minus 2x. Right, and if you're not confident with your fractions, do just double check on the calculator. So that's minus 5 over 2 plus a half, which is 0.5, which gives us minus 2. Great, and now let's distribute the 4. So 4x squared minus 8x, 4 times negative 5 over 4 is negative 5. Now if you look back at our original equation, you see that 4x squared. You also see minus 5 and equals 0. So all of that's the same, which means b, which is what we're looking for, must be equal to negative 8. And then we're done. But if you wanted to double check your answer, what you could do, so check, is substitute b equals negative 8 back into the solution, right, which gets this, which is actually the same as that. But when you're here, you can solve for x, right, find the solutions. So I'll just do that on my calculator really quick. So do this if you have a few extra minutes at the end of your exam. So menu, equate, polynomial, f2, degree 2 because it's a quadratic, f1, a is 4, right, the coefficient of x squared, b is negative 8, c is negative 5, f1 to solve, and we get x must be 5 over 2, or negative half. Which means we were right, and we can just give ourselves a tick, save the marker some time.